In this module, we will examine the fire protection system of the ATR 42. We will start out with a brief system description. Next, we will look at the fire detection and protection system for the engines as well as smoke detection for the cargo compartments and the lavatory. Following that, we will look at the avionics compartment smoke detection system. Each engine incorporates a fire detection and fire protection system. The right engine nacelle also incorporates an overheat detection system that operates when the aircraft is on the ground. Overheat is detected in the right engine nacelle. The centralized crew alerting system will provide a warning to the crew. The forward and aft cargo compartment each have one optical smoke detector. The cargo compartments are protected by a fire protection system. The lavatory uses a photoelectric smoke detector to provide an alert in the event there is smoke in the lavatory. A small fire protection bottle protects the lavatory waste bin. A smoke detection system monitors the air between the avionics compartment and the extract fan. This system is linked to the centralized crew alerting system and provides a warning to the crew in the event avionics smoke has been detected. Various fire protection bottles are located throughout the aircraft. The controls and indicators associated with the fire protection system are located on the overhead panel and the condition levers. Each engine incorporates a fire detection system. The system consists of two identical detection loops called Loop A and Loop B. These loops are parallel to each other, and they are connected to a fire detection control unit. The loops are powered by the DC emergency bus. The right nacelle incorporates an overheat detector which works when the aircraft is on the ground. If the right nacelle temperature exceeds 170 degrees Celsius, the nacelle 2 overheat light illuminates on the crew alerting panel, the master warning lights flash, and a continuous repetitive chime will sound. In the event of a nacelle overheat warning in hotel mode, the right engine power lever should be brought to ground idle and the condition lever to feather, then fuel shutoff. If a nacelle overheat happens on taxi, it is usually caused by a tailwind. If this is the case, the corrective action is to stop the airplane and increase the power slightly. If an overheat still exists after 30 seconds, the right engine should be shut down. Each detection loop consists of a nickel core coated with a thin eutectic salt-based layer. This core is contained in a sheath made of stainless steel. The salt changes resistance with changes in temperature. As the temperature rises, the resistance of the salt decreases and the flow of current through the nickel core increases. The electrical signal flows in a continuous loop to the Fire Detection Control Unit, or FDCU. The FDCU measures the resistance in the loop as well as the capacitance. The FDCU will trigger a fire warning if there has been a decrease in resistance and an increase in capacitance of both fire loops. Both loops must detect a fire in order to trigger a fire warning. If an engine fire has been detected, the continuous repetitive chime will sound, the master warning light will flash, the associated fire handle will illuminate red, a red fuel shutoff light will illuminate in the associated condition lever, and the associated engine fire light on the crew alerting panel will illuminate. The integrity of the loops is continuously monitored. If a fault is sensed in one of the loops, a fault light will illuminate in the associated loop push button, and a loop light will illuminate on the crew alerting panel. In addition, the master caution lights will flash and a single chime will sound. If the fault light in a loop push button illuminates, it indicates that the associated loop has faulted and therefore must be deselected. If it is not deselected, the system will not be able to detect a fire since both loops must be in agreement. The affected loop is deselected by releasing out the push button with the illuminated fault light. This reconfigures the associated fire detection system so that only the other fire detection loop is used to detect an engine fire. Click on the loop light with the illuminated fault light to reconfigure the system. If there were a break in one of the loops, the system could still detect a fire since both sections were still connected to the controller. However, if there are two breaks in a loop, there would be a segment of the loop that is not connected to the controller, and this section would be unable to detect a fire. In this case, the loop fault light would illuminate on the overhead panel. It would also be accompanied by an amber loop light on the crew alerting panel and a single chime alert. Note that a broken loop would cause a decrease in the resistance of the circuit. But since there were no increase in capacitance, a fire warning would not be triggered. Conversely, excessive heat in an engine compartment can trigger a fire warning even if there is no fire. For instance, from a bleed leak. In this case, don't fire the bottle until it is determined that closing the bleed valve doesn't silence the fire warning. Once a loop has been deselected, the off light in the associated loop push button illuminates. The engine fire protection consists of two fire bottles. The fire bottles contain halon gas pressurized to 600 psi. The fire bottles are located on each side of the fuselage. The plumbing of the system allows the content of either bottle to be used to suppress a fire in either engine. The gas in the fire bottles is retained by seals. There are 2 seals per bottle. Gas is released into an engine by firing a squib which punctures the associated seal and allows the halon to flow through the associated line and into the associated engine. The squib consists of a pyrotechnic charge that is electrically detonated. Each squib can only be fired once. When a fire bottle has been discharged, the discharge captions on the associated squib push button of both fire panels will illuminate. They both illuminate since each push button is connected to the associated bottle. The fire bottles are plumbed to the engines in such a way that firing Agent 1 into one engine is the same as firing Agent 2 of the other engine. For example, if you fire Agent 1 into the left engine, the Agent 1 discharge light illuminates on the overhead panel for that engine. At the same time, the Agent 2 discharge light illuminates for the right engine on that side of the overhead panel. Two identical engine fire panels are located on the overhead panel. Each incorporates a fire handle, loop push button, and two agent push buttons. When a fire has been detected, the associated fire handle will illuminate red. In addition, the continuous repetitive chime will sound, the master warning light will flash, a red fuel shutoff light will illuminate in the associated condition lever, and the associated engine fire light on the crew alerting panel will illuminate. Click on the illuminated fire handle to continue. The fire handles are mechanically locked by safety-wired spring latches. A latch can be thumb-released in order to allow the fire handle to be pulled down. Make sure that the handles are pushed in prior to pre-flight checking the system. It should be noted that the fire handle will remain illuminated as long as a fire is detected. This is true regardless of the fire handle position. The light will only extinguish after a fire is no longer detected. Pulling on the fire handle will arm the associated squibs on each fire bottle. The arming of the squibs is indicated by the illumination of the squib light on each fire panel. Pulling the fire handle will also close the associated engine's bleed and high-pressure bleed valves. Closes the associated engine pneumatic de-ice valve and isolation valve. Trips the associated DC and AC wild generator fields. Closes the engine's low-pressure fuel valve. And runs the electric feathering pump to feather the propeller. The procedure calls for shutting down the affected engine prior to pulling the fire handle. Pulling the fire handle prior to shutting down the engine closes the low-pressure fuel shutoff valve. This may result in a collapse of the associated fuel line and prevent the restart of the engine should a restart be required later. After the fuel is shut off, the light in the associated condition lever will extinguish. This light will also automatically extinguish after a fire is no longer detected. After a fire handle has been pulled, one of the fire bottles can be discharged into the engine by pressing one of the illuminated squib lights. Pressing a squib push button sends an electric charge to the associated squib, which fires and punctures the associated seal. This releases the halon into the associated engine. Click on the number 1 squib push button to fire the bottle into the left engine. When pressure in the fire bottle drops below 225 psi, a pressure switch is activated which illuminates the associated discharge light on the fire panel. As mentioned previously, the discharge light illuminates on both fire panels. If Agent 2 is used on Engine 1, the Agent 1 light on the Engine 2 panel illuminates discharge. The engine fire protection system is tested with the test switch on the fire panel and is used during the pre-flight. The switch is spring-loaded to the neutral position and enables the selection of a fire test or a fault test. Click on the fire position to test the fire protection system. With both loops selected on, the fire test position will illuminate the associated fire handle, illuminate a fuel shutoff light in the associated condition lever if the lever is not in the fuel cutoff position, the red master warning lights will flash, a continuous repetitive chime sounds, and illuminates the associated engine fire light on the crew alerting panel. Placing the test switch in the fault position will test the loop circuitry for any faults. Click on the fault position to test the fault circuitry. The fault position tests the detector loops. The indications of a successful test consist of the illumination of the fault lights in both Loop A and Loop B push buttons, the master caution lights flash, and the loop light on the crew alerting panel illuminates. In addition, a single chime will sound. The squib test push button is used to check the continuity of the squib circuitry. Pressing the test button sends a test signal to the squibs. The signal is the same one that fires the squib but uses a weaker current. The test is successful if both squib lights illuminate. If either squib light fails to illuminate, it indicates a problem with the associated squib. Three smoke detectors are installed on the passenger configuration aircraft. One detector is in the forward cargo compartment, and another one is in the aft cargo compartment. The third smoke detector is in the lavatory vent line. The smoke detectors are powered by the DC Essential bus. The detectors sense the presence of smoke and do not detect fires. The cargo smoke detectors measure reflection of light from a projector. When light is reflected, it indicates the presence of smoke. The lavatory smoke detector is equipped with a photoelectric smoke detector. A smoke warning is triggered when smoke is detected by this sensor. Three extract fans move the air through the compartments and circulate the air past the smoke detectors. One fan is located in the forward cargo compartment, and two are located in the aft cargo compartment. Only one of the aft cargo fans runs at a time. The extract fans are powered by the AC standby bus. The operational fan for a flight is swapped each time the DC essential bus is powered up. The crew cannot determine which fan is operational. If one of the fans fails, a CCAS alert is activated and the fault light in the aft compartment lav detector fan's push button illuminates. The alternate fan can be selected by pressing the aft compartment lav smoke detector push button. This will cause the alternate caption to illuminate in the push button. If smoke is detected in the forward or aft cargo compartment, it will be indicated by the flashing of the master warning lights, the continuous repetitive chime will sound, and the forward smoke or aft smoke light will illuminate red on the crew alerting panel. If the fire indication is from the aft cargo compartment in the passenger configuration, there is no indication of whether the smoke has been detected in the aft cargo compartment or the lavatory. The cabin crew is used to make that determination. On some aircraft, a panel will indicate the location of the smoke. Smoke warnings cannot be canceled and they are inhibited during the takeoff. The cargo compartments do not incorporate a fire suppression system. However, a portable fire extinguisher can be used to discharge the content of the extinguisher bottle through a port that is installed in some aircraft near the flight attendant panel. After the extinguisher has been plugged into the extinguishing port and completely discharged, the cargo compartment will need to be opened in order to verify that the fire is out. On cargo-configured aircraft, Zone 1 is plumbed to a fire extinguisher located behind the first officer's seat. It is also fitted with a stainless steel floor pan and should be used to contain flammable goods and corrosives. A small automatic fire bottle is located in the lavatory. The tip of the fire bottle is directed to the wastebasket and consists of a fusible plug. The plug will melt when the temperature exceeds 78 degrees Celsius. There are no indications in the flight deck of the discharge of this fire bottle. A fan extracts air from the avionics racks and the flight deck. A smoke detector is located before the extract fan. If smoke is detected, it will illuminate the red electric smoke warning light, the continuous repetitive chime will sound, and the master warning lights will flash. If the red electric smoke warning light illuminates and you do not detect any smoke in the flight deck, it indicates that the smoke is coming from the avionics compartment. This concludes the fire